Welcome to the DIY Honda Garage channel. DTC P0703 refers to a malfunction concerning the brake switch NC, normally closed, for Honda Civic models from 2011 to 2015. This code indicates that there is a problem with the brake pedal position switch signal, which affects the vehicle's ability to control systems like cruise control and idle-stop functionality. Specifically, this malfunction could potentially lead to safety concerns as it indicates that the brake system may not operate as intended. The brake pedal position switch is usually located near the top of the brake pedal, ensuring that it is engaged when the pedal is pressed. If this switch malfunctions, it can cause issues with other electronic systems that rely on this signal. In some situations, simply pressing the brake pedal for an extended period may inadvertently lead to this code being stored in the vehicle's computer system, highlighting the importance of thorough diagnostics before making repairs. The error indicated by DTC P0703 directly impacts the brake switch position, which plays a crucial role in the vehicle's operation of several systems. This brake switch generally informs the Honda Civic about whether the brakes are applied, which affects functions such as cruise control and the idle stop feature. Positioned at the upper pivot of the brake pedal, this switch is designed to activate when the pedal is pressed, signaling to various control units within the vehicle. If the signal from this switch is faulty or never activated, the resulting Diagnostic Trouble Code will be triggered. Additionally, other possible causes for this malfunction can involve wiring issues or a failure in the brake pedal switch itself. Hence, addressing this DTC P0703 requires a meticulous approach to ensure all systems reliant on the brake switch function appropriately. Understanding the possible causes of DTC P0703 is vital in determining the root of the problem. One potential cause is a faulty brake pedal position switch, which may fail to provide the necessary signal indicating the brake system status. Another cause could be improper installation of the switch, affecting its ability to engage properly when the brake pedal is depressed. Wiring issues are also common and can include damaged or shorted wires leading to the brake pedal position switch or the related control modules. Poor connections or corrosion can exacerbate these issues, leading to erratic behavior of the switch over time. In diagnosing this trouble code, careful inspection of all electrical connections and components related to the brake pedal position switch is essential to ensure full functionality. Symptoms associated with DTC P0703 can manifest in various ways, indicating the underlying issue. A common symptom is the malfunction of the cruise control system. The inability for the vehicle to recognize brake application may lead to system disengagement under unexpected conditions. Additionally, the idle stop function, designed to save fuel by stopping the engine at idle, could also experience hiccups, leading to unresponsive or erratic behavior. Drivers may notice the brake warning light illuminating on the dashboard, signaling a brake system issue that warrants immediate attention. Other less obvious symptoms, such as a lack of responsiveness when depressing the brake pedal during cruise control, can also occur, making it crucial for drivers to be vigilant. Recognizing these symptoms early helps to prevent more significant issues down the line. The first troubleshooting step for addressing DTC P0703 involves checking the brake pedal position switch signal with the Honda Diagnostic System HDS. Begin by turning the ignition switch to the on position or pressing the engine start-stop button to achieve the on mode. It is crucial to perform this check without depressing the brake pedal. Once in the diagnostic mode, examine the cruise brake SW, idle stop SW reading on the HDS. If a close indication appears, This means the brake switch signal is functioning correctly, and it suggests that the issue may not lie with the brake pedal position switch itself. If close does not appear, proceed to the next step for further diagnostics. This step is essential, as it provides an initial indication of whether the switch is operational or if further inspection is necessary. In the second troubleshooting step, the focus shifts to the installation of the brake pedal position switch. First, turn the ignition switch to the lock position to ensure safety before proceeding. After that, adjust both the brake pedal and the brake pedal position switch to ensure they are aligned correctly and functioning as intended. Once adjustments are made, turn the ignition switch back to the on position or push the start-stop button to select on mode. Following this, check the cruise brake SW idle stop SW once more with the HDS, again without pressing the brake pedal. If the reading shows close, the issue is resolved, indicating the brake switch is properly installed and functional. However, if it still shows no, additional troubleshooting is required to diagnose further complications related to the switch itself or other components. Step 3 requires determining the potential failure area more specifically. After turning the ignition switch back to the lock position for safety, disconnect the brake pedal position switch 4P connector. Once disconnected, utilize a jumper wire to connect terminals A and B within the brake pedal position switch 4P connector. Specifically, connect terminal A, wire number 3, typically brown, to terminal B, wire number 4, typically yellow. Following this step, turn the ignition switch back to the on position. It's essential to wait approximately 2 minutes to allow the systems to stabilize before verifying the signal on the HDS. Check if the cruise brake SW idle stop SW reads close. If it does, this indicates that there is a fault in the brake pedal position switch, necessitating its replacement. If no is indicated instead, further testing is needed to pinpoint the issue's root cause. In this fourth troubleshooting step, the focus shifts to the IG1_ACG line and potential other electrical issues. Begin by turning the ignition switch back to the lock position to ensure safety. Once this is done, disconnect the jumper wire from the brake pedal position switch 4P connector. With the switch now disconnected, turn the ignition back to the on position and wait 2 minutes. During this waiting period, you'll need to prepare to measure the voltage between 2 specific test points: the brake pedal position switch 4P connector number 4, the yellow wire, and the body ground. This is essential for diagnosing any wiring issues present. If you determine that there is battery voltage present at this point, it can be concluded that the IG1_ACG line is intact with no other wiring. Conversely, if voltage is absent, you must navigate back to earlier steps to examine wiring integrity further. Step 5 involves checking for an open circuit in the BKSWNC line, which is vital for the functionality of the brake switch. First, turn the ignition switch back to the lock position to ensure safety before proceeding with the diagnostics. Jump the SCS line with the HDS to prepare for further checks. Following this, you'll need to disconnect the PCM connector A, which contains 49 pins. Now, similar to previous steps, use a jumper wire to connect the brake pedal position switch 4P connectors terminals 3, brown, and 4, yellow. Once these connections are made, set the ignition switch back to the on position. Measure the voltage between the designated test points, PCM connector A pin number 25 and body ground, while maintaining the jumper connection. If you find battery voltage present, this indicates that the BKSWNC wire is functioning correctly. Therefore, you may want to update the PCM software or replace it if required. If no voltage appears, then there could be an open circuit that needs immediate attention. In the sixth troubleshooting step, a critical inspection of the fuses, specifically fuse number B210A, is key to identifying issues. Initially, turn the ignition switch back to the lock position to prevent any hazards. Next, locate fuse number B2 within the under-dash fuse relay box and perform a visual inspection to determine whether the fuse is intact. If the fuse is blown, which may be indicated by a broken filament inside the fuse, it will need to be replaced. If the fuse is operational, this suggests that the IG1 ACG wire also remains unbroken and functional. However, if there's a short in wiring between the brake pedal position switch and the number B2 fuse, repairs would be necessary to restore proper function. Identifying the status of this fuse is essential for ensuring that the electrical circuit related to brake operation is safe and fully functional. The seventh troubleshooting step emphasizes the necessity of checking the brake pedal position switch signal for any intermittent failures. First, turn the ignition switch to the on position to engage the necessary systems for the HDS diagnostics. Next, press down on the brake pedal to fully engage the switch and take note of the reading on the HDS. If the cruise brake SW idle stop SW indicates an open reading, it suggests a momentary fault. This can occur if the connections are loose or exhibit poor contact. It is crucial to check for any potential loose terminals or poor connections at both the brake pedal position switch and the PCM. Should the system have freeze data or an onboard snapshot of this DTC, attempt to replicate the failure under similar conditions to ascertain whether it's a persistent fault or an intermittent one. Accurately gauging this signal is critical for determining the next course of action in addressing DTC P0703. In the final troubleshooting step, the brake pedal position switch undergoes a comprehensive inspection to verify its operational status. Begin by meticulously checking the functionality of the brake pedal position switch itself. If the switch is found to be operational and functioning correctly, yet issues persist, this might indicate a short to power in the BKSWNC wire located between the switch and the PCM. In such cases, thorough testing of the wiring is imperative to identify any faults. However, if the switch is deemed faulty after inspection, it must be replaced to restore proper function to the brake system. Given the critical nature of this component in controlling numerous vehicle systems, ensuring its reliability is crucial to maintaining a safe driving operation. In conclusion, effective troubleshooting procedures are vital in arriving at a resolution to the DTC P0703 issue, restoring normal functionality to the braking system. The final repair verification stage is essential to ensure that all systems are back to optimum operational status following the troubleshooting of DTC P0703. After carrying out repairs or replacements for affected components, confirm that all related systems are functioning properly without any warning lights activating on the dashboard. The next step is to clear the Diagnostic Trouble Code DTC from the vehicle's memory using the HDS. Subsequently, conduct a test drive under various driving conditions to simulate normal operation of the vehicle. While on the road, pay particular attention to the braking system's responsiveness and the functioning of the cruise control and idle stop systems. After the test drive, monitor for the recurrence of the DTC. If it appears again, additional diagnostics will be necessary to identify any underlying issues that may have been overlooked during earlier troubleshooting steps. Preventive maintenance plays a critical role in avoiding future occurrences of DTC P0703 and ensuring the longevity of the braking system. Regular inspections of the brake system, including the brake pedal position switch and its wiring, can help catch any wear or potential failures early. Additionally, it is crucial to check all wiring connectors for signs of wear, corrosion, or poor connections that could adversely affect signal transmission from the switch. Keeping the software of the Powertrain Control Module, PCM, current is equally important, as manufacturers often release updates to optimize performance and resolve known issues. These preventive tips not only safeguard the integrity of the brake system, but also enhance overall vehicle safety. A proactive maintenance schedule can greatly reduce the risk of encountering DTC P0703 in the future, ensuring smooth and trouble-free vehicle operation. In conclusion, DTC P0703 represents a critical malfunction related to the brake switch signal on Honda Civic models from 2011 to 2015. Proper troubleshooting involves a sequential approach, starting from basic checks of the brake pedal position switch signal to inspecting wiring, replacing components, and verifying operational integrity. Clear indicators and symptoms associated with this DTC can assist in guiding technicians toward effective resolutions. Implementing preventive maintenance practices is equally significant in mitigating the risk of this code reappearing in the future. By keeping the braking system in peak conditions, addressing possible wiring issues early, and ensuring software updates, vehicle owners can significantly enhance the reliability and safety of their Honda Civic. Therefore, awareness and diligence in troubleshooting and maintenance will lead to a better driving experience and operational safety. Please like and subscribe to the channel. See you next time.